All right, here we go. All right, give me something. Hey, give me something you remember about this kind of function called the exponential function. What? It's exponential. Good. But what does that mean to you?
The little number at the top.
Does that mean it keeps growing?
It keeps growing. Called exponential what? Growth. And then there's another name, exponential decay. Okay. What else? What? Ooh, logarithms. Well, here's the deal. When you say that, you're actually saying the inverse function of exponentials is logarithmic. We're not there yet. Don't get into logarithmic yet. Okay, here's what I've got. I heard it grows. I heard it decays. And this is the way it does look. I heard there's a little exponent or something going on. The only thing about that is today the exponent is your what? Variable. It's your variable. So when you have a variable exponent, you have an exponential function. Okay? We'll get into a whole bunch of things now. Let's just keep going. Okay? All right. So what's the definition of an exponential function? It says here the exponential function f with base a is denoted by this look. A to a power of what? X. Where a is known as the base. X, that's your variable. So I today will give you this a value, I'll give it to you. It could be 2 to the x. It could be 6 to the x, 12 to the x. I'll give it to you. All right? Where a must be what though? So I got to give you 2, 4, 6, 8 to the x. Can I give you negative 2 to the x? No. No, I can't do that. A can't be what? A can't be 1. And x, the variable, has to be what? Any real number. Okay? Why? Why can a not be 1?
1 times 1 times 1 times 1 is still 1.
So if a is 1, f of x equals 1 to the x.
It's 1.
Yeah, any number I put in for x, the answer will always be what? 1. So what does that graph? This forms a what? I heard somebody say it. Forms a horizontal line. You could say y equals 1 right there. Here it is. This is the look you would get if you let your base be 1. And there's a name for this function. It's called the what function? It's the constant function. You guys actually looked at it in lesson 1-6. I said, what's the constant function? It's a horizontal line. 1, 1, 1, 1, 1, 1. The answer is always 1, right? Okay, let's get some practice. How do I raise things to powers of whatever? Well, some of these you can do without a calculator. Pick them. Pick the ones you can do without a calculator. 9 to the what?
9 to the 1
Okay.
half. Don't you just
Okay, no, that's good. What else can you do?
4 squared.
4 squared. Good. What else?
4 squared is 26.
2 to the 6. What else?
8 to the 2/3.
8 to the 2/3. What else? Mm-hmm. There you go. So those are the ones you come up with what? Exact answers. These, that's your calculator. I can't do that. You do that with your calculator. Go get the exact ones. Okay? Which means you don't need your calculator. You don't have to go reaching for your calculator. Not yet. Do those without a calculator.
16 fractions. 32. 61.
What was it?
64.
So I picked on the two that I thought, wow, those are so easy. How about 9 to the 1/2? What? Square root? Okay, if you guys remember, last year in Algebra 2, when you get an exponent that's a fraction, the number on the bottom is called the what? It's called the root. And the number on the top is called the power. So you guys, take 9 and do what? Find the what root?
Second root.
Square root of 9. Whatever you get, raise it to what power? The first. Well, that's pretty easy. Square root of 9, 3. 3 to the first? 3. Which tells me now you can do that problem, right? I hope.
Yeah.
Okay. What do we do to 8 and 8 raised to the 2/3? What root are we looking for? The third root of 8, which you know. Then raise it to the what power? Second power. This is what? 2. Second power. Honestly, guys, it would take you longer to type that in. Because in my mind, I do this. Cube root of 8, 2. 2 squared, 4. And then. That's how quick I do that. You don't need your calculator all the time. You guys can do that. Now, this is weird because now the exponent is what?
Negative.
Negative. Now, you have to kind of know your rules from Algebra 2. Negative exponents. What did you do? And what?
Flip it? Or
Flip
is it
it.
just like 2 times negative 2 times
But wait a minute. You said flip it. What's it?
It becomes 1 over 2 to the third.
Okay. You're just telling me what to do. When she said flip it, she's
Base.
saying flip the what?
Base.
Yes. Flip. I'll write you a little note. Flip the what? Base. If this is 2 over 1, you'll write what?
1 over 2.
1 over 2. And now the nice thing is, once you flip the base, guess what the exponent becomes? Positive 3. Again, you can do this without your calculator. 1 times 1 times 1
This one.
is 1. 2 times 2 times 2 is 8. 2 to the negative third is really just 1 over 8. You guys remember doing that? Yeah? So if I go like this to you, what are you going to do?
1/5 to the third.
1/5 what?
Third.
Like this? And then what?
And 1.
Doesn't that just mean this? I'm just, right?
125.
Isn't that all it means?
625.
1 over what?
125 is 25 times
Right? Isn't that what it means? Okay. Can I show you how I do it? Okay. Guys, you don't have to make this so complicated. Here's what it is. Here's me thinking, if this is 5 cubed, just ignore this. Just ignore the negative. 5 times 5 times 5 is what? 125. But the exponent was negative, so the answer is not 125. You know what it is?
1 over 1.
It's 1 over 125. So in my head, I go, what is 5 to the third? 125. But it's not. It's going to be 1 over 125 because I have to flip the base. I do it that quick. Now, this is really the work behind it to get to that answer, but do you have to show all that work? Not really. You guys are Algebra 2 and pass. If you guys got that background in Algebra 2, do it a little quicker. But what I'm trying to tell you, you don't need to calculate, right? Okay, go back and do this one to the nearest hundredth. Where is it? This one. 4 raised it to the pi power is roughly, I heard 77 point what? 0.88. Okay, good. Okay. 3 raised it to the square root of 3. 6.7. Give me one more number.
0, 4, 9.
Wow. We'll stop there. You guys agree? Yeah? Okay. And move on? Okay. All right, here you go. Let's do a little bit of graphing. Would you please graph enough points to sketch y equals, I'll just call that y, equals 2 to the x. Pick enough x values that get you a good picture. So what are some easy numbers to put in?
2, 1, 0, 2.
Oh,
There you go.
Negative 1, negative 2, 0, 1, 2.
Negative 2, negative
Shit.
All right. We can go though.
Shit.
Yeah, that's what I always do negative 2 to 2.
Let me start with the easy one. 2 squared is what? 2 to the first is what?
2.
2 to the 0 is what?
1. 1. I just put it in. It's 1.
But that would mean that there's 0. What?
1. Hey guys, by definition, any number raised to the 0 power is what?
1.
1. So if I say 2 to the 0 is 1, what's 3 to the 0?
1.
27 to the 0.
1.
How about negative 27 to the 0?
1.
1. Any number raised to 0 is 1. Okay? Now let's go here.
What's the math?
What about 1/2? What about
1/2?
2 to the
Negative
negative
two.
1? That's really 1 over 2 to the what?
1.
First. So that's 1/2. Yep. What about negative 2?
1/4.
Okay. If you went and graphed those points, I'm going to go every other square. 1, 2, 3, negative 1, negative 2, negative 3. Okay, something like this. Okay, so 0, 1 is here. 1, 2. 2, 4. Can you see it already? It's climbing really fast, isn't it? And then on the other side, it's going to be negative 1/2, negative 2, 1/4. There it goes, there it goes. Okay. Now here comes my question to you. Do you see that if you plug in 3, you will get an answer?
Yes.
What is it? 8. Okay. So this thing keeps rising and rising, and it keeps moving this way, right? Forever? Okay, so it does go this way, up and that way. But on this side, when does it hit the x-axis? Never?
Never.
You sure?
Yes.
So if I go negative 10, you're saying it's never going to hit.
It's just going to go like right along.
Okay, let me check it out. Ready? What was it? 2
Yes.
to the negative 10,
2.
which is really flip the base, 1 over 2 to the what? 10. What's 1 times 1? 10 times. 1. 2 to the 10th. You might want to take that in. 1,024. Is this number still above the x-axis?
Yeah.
Yes. So you know what's happening here, guys? This graph has a what? What kind of asymptote? Horizontal. So you should put a note here. HA. Horizontal asymptote of y equals what? 0. There you go. All right. So there's a name for this kind of graph. If it starts out really low and starts to climb slowly, but then takes off, there's a name for this. It's called exponential what?
It's just gotten too small.
Growth. Okay. So that is a growth kind of function. Okay. All right. Any questions? Okay. I think the next slide is about the characteristics. Yeah. So what did you just graph? Well, here's what you graphed. You did a y equals a to the x graph where a was what? Greater than 1. A is your what?
Base.
Base. If your base is greater than 1, then the domain will always be this, all real numbers. Think about it. Did negative 5 get an answer? Yeah. Did 5 get an answer? Yeah, eventually. Okay, what about the range? The y values that came out of this thing are going to be what? Greater than 0. How come? Well, look. See this? All these points, they all go with what kind of y's?
Real one.
Well, real, but all y's what?
Positive.
Greater than 0. So this is the domain. This is the range. There are no what? How come? Why? Because there's a horizontal asymptote. Where? At y equals 0. So why? Because of this reason right there. The y-intercept will always be what?
0, 1.
0, 1. It doesn't matter what function I give you. If I give you 2 to the x, if I give you 3 to the x, or 4 to the x. Guys, if you put a 0 here, 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 you tell me the answer every time. What's the answer? 1. 1, 1, 1. It's always 1. 0, 1 is always on your graph. It's a dead giveaway. Okay? Your function is always what? Increasing this way. And it's called 1 to 1. Why 1 to 1? Vertical line test, it passes. Horizontal line test, it passes. That horizontal line test, that was to determine if it had an inverse. And it does have an inverse. Emma, she already told you the inverse, but I'm not going to tell you until Wednesday. Okay? Okay. The graph always contains the points. What points? 0, 1. I already said that right here, by the way. And what? 1, comma, A. What's A? A is the base. Okay? So if I gave you this, 5 to the x, what does this say? If I put what in? If I put 1 in, what's the answer, guys? It's the base. That's what that says, 1 comma base. The graph is smooth and continuous. I think you can see that. All right, do that one. Graph another one. This one, it's like the other one I had you graph. It's just that it's not 2 to the x, it's what? It's the reciprocal. Yeah, it's the reciprocal base. Sorry, it is 1. I'm trying the same numbers as we tried before. Yeah, then we're gonna talk about that in just a second. What's 1/2 raised to the 0 power? 1. I'm trying to hammer that in your head. Is anything to 0 is 1. Okay, what's a half raised to the first? 1/2. What's a half raised to the second? 1/4. What's a half raised to the negative 1? Flip the base. The base would be 2 then, and then change that to 1. Now the answer is what? 2. Yeah? What's 1/2 raised to the negative 2? 4. What do you notice about our answers compared to the 2 slides ago? Same answers, they just got what?
Switch.
They got turned around, and when you graph it, guys, here's what it looks like. 0, 1, 1, 1/2, 2, 1/4. It goes like that. There's 2. There's 1, 0, -1, -2. Here you get 2. Here you get 4. See it? Like this. Like this. And doesn't this kind of look like, by the way, this is 1/2 to the x. This is what? This is going to be 2 to the x. So tell me this. If you take your base and you flip your base, I went from a 2 to an x to a 1/2 to the x. What do you notice about the graphs?
Just opposite.
No, don't say opposites. The reflections over the what? The what x?
Why? You guys.
Yeah.
1/2 to the x is a reflection of 2 to the x over the what? Over the y-axis. That's what I want you to realize, okay? That's really all there. One's called decay, one's called growth. Which one's growth? Wherever the base is what? Greater than 1. Where is it called decay? When the base is less than 1, right? Okay, and they're going to talk about decay right now. So let me go like this. Okay, the graph of y equals a to the x, where a is between what number? 0 and 1. And by the way, a is the base. Okay, if the base is between 0 and 1, then you have all the same properties as the graph when a was greater than 1, except f is now what?
Decreasing.
It's decreasing. And the reason this decreased is because your base was where? Where was your base here, guys? Less than 1, but greater than 0. That's the only reason you have that look, because your base is between 0 and 1. If your base is bigger than 1, you have growth going on, and that's not growth, that's decay. This is your growth. Because you have a base bigger than 1. Are we good?
Yes.
Okay. Ready? Using the parent function y equals what? 3 to the x. And the transformation. Sketch the graph of this. So guys, get that one graphed, and then go graph that one using your transformations. Okay? Right to, up to, down to, stretch it by 2, stuff like that. Okay?
So we have to describe it?
You know, you should describe it to yourself, but then you have to graph it. I need 2 graphs.
Okay.
Get me the parent, and then get me the real one. If you get the parent wrong, are you going to get the function wrong? Yeah. So let's make sure we have the parent right. What are the 2 easiest points, x values to put in?
0.
Put in a what? 0. And put in what else? 1. That's it. Guys, that's all you needed. So what's 0? 3 to the 0? 1. 3 to the first?
3.
3. That's all I need. Do I know if it's growth or do I know if it's decay?
It's growth.
Okay, it's growth. So here we go. 0, 1 here. 1, 3. Here. Okay. So I know it's this, right? And I know it rides on top of the x-axis, right? There it goes. What is this? 3 to the what? X. All right. Now, you tell me what all that stuff means. What does that stuff mean? Like inside grouping symbols. What does that mean? That's what? Right to units, right? Correct, I mean? Okay. Right 2. That negative sign out in front, that just says negative 1 times 3 to the x minus 2. Okay, the number 1, is that a stretch or a compression? Or nothing? 1 is nothing. Okay, so that's not stretching, that's not compressing. Is that mean anything, that negative?
Reflection.
That's a reflection over what? Over? Reflect over what? Who says x? Who says y? Who says I don't know? It's a reflection over x-axis. When it's in front of your parent, it's the x-axis. When you switch, hey, if I would have switched the x value, 3 to the x to 3 to the negative x, now it's over the y-axis. Okay, so here we go. 1, 2, that's 2. So I go right 2, now what? How do you reflect this over? How far down do I go? 1 down. I'm 1 up, now I'm 1 down. How about this one? Okay, I'm going to go 1, 2, that'd be 3 here. Okay, reflect it. Now I'm up 3, now I'm going to be what? Down 3. There's 3. There's negative 1. There's negative 2. Okay, there it goes, there it goes. Hey guys, look what happens here. Up, 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 up. Guess what yours is going to go? Down, down, down. Okay? Here it comes. What about the horizontal asymptote? Where's it go? Where's it going to go? Where do I keep? It's going to right on the bottom of the x-axis? Okay, check it out. Ready? Go like this. Jump on the graph right here. You know you're going to go right what? Right? To reflect it what? Yeah, that much. Not much at all. So guys, it does go like this, right? Right? So now it rides under the x-axis. So what would be the horizontal asymptote on this one? HA? Y equals what? 0. Except it's where? Below the x-axis. Where the other one is above the x-axis. So here's my last question on this horizontal asymptote. When does the asymptote move around? Say again. So give me an example.
So like if it was negative 3 x minus, or to the power of x minus 2 minus a number.
So you're saying this same thing I gave you.
Yeah.
Then what?
Plus or minus a number.
Plus or minus a number. So if I said plus 3. Yeah. You know what that plus 3 did? That plus 3 moved the entire graph where? Up 3. So guys, now, just so you know, I mean, I'm not going to do this perfectly, but 1, 2, 3. Here is the horizontal asymptote. You would have got the same graph, but your graph would have looked like this instead. Because of what? Because of what? That plus 3 moves everything up 3. So the horizontal asymptote, that moves up 3 too. And you would know because remember this point, 0, 1. Didn't I do this? Watch. Right, what did I go? Right 2? I went right 2 and then I flipped it over, right? And then I have to go what? Up 3. And I'd be like right there. It would work. You guys would see that it works. But this is the only thing that's going to move that vertical horizontal. Yeah. Are you okay? Hang on here. Did I skip a slide? No? Okay. Yeah? Yes, I did. There it is. I skipped it last hour too. So you know what I'm going to do? I'm going to skip it again. Just one. Okay, I'll come back to it later if I can. I want to get this one in. Okay, this is you solving exponential equations. There are special cases that make exponential equations solvable. It's called the one-to-one property, and this is what it looks like. For you to solve, you just need your base to equal what? The base. If your bases are the same and your exponents are x and y, what do you know about x and y? They have to be equal, don't they? So guys, this number right here and this number right here, they have to be what? Don't they have to be the same? So like if you look over there, guys, I got base 3, base 3. Are they equal, the bases? Guess what these exponents have to be? They have to be the same number. It's got to be 3 to the 10th equals 3 to the 10th, or 3 to the 12th equals 3 to the 12th. So what do you do to those exponents? Set them equal to each other. When is 2x minus 1 going to equal x plus 2? That's all you got to do. It's so easy. So, what'd you get? 3, didn't you? Good? Easy. As long as the bases are what? The same. Okay, look. Base 5. Base what? 25. Are they the same? No. We got to change them. We got to get them to look the same. So, this is what takes work, and this is why students get this one wrong. You have to make them both base 5, or base 25, base 25. Which one seems easier to change?
Oh, no, make them both base
You want them 5, base 5 equals base 5. Okay. Here we go. You like 5? I like 5. I won't move this one. Okay. Can you see this 25? I need to change it. I need to change it to something else. What? You said you want base 5. I'll put base 5. 5 squared. Would you guys agree 5 squared is just 25? Yeah, so now I have base 5 equals base 5, but here's the problem. I have a weird look. I have base 5 squared raised to the x plus 1.
So then you have to distribute this square.
Okay, you have to do this. You have to know that. Do you guys remember this at all? From 9th grade or 11th grade? 2 to the 2nd raised to the 3rd is 2 to the
6.
multiply a power to a power. Okay. How about this? 2 to the 2nd raised to the x. What's the answer? 2 to the 2x. What's this? 2 squared raised to the x minus 5.
2 is 2x minus 10.
Yeah? Guys, this is stuff you learned in Algebra 2. Power, raise to the power, multiply, 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 and you get these powers. Go back to that problem we were just working on. Okay? That one right there. So you changed 25 to base 5. So this one, I'm just going to write it like this. This one would become what? 5 to the 2x plus 2. Oh, I got base 5 equals base 5. Set the exponents equal to each other. And you get, yeah, this one I move this way, x plus 2 equals negative 4. X equals what? Yeah? That problem wasn't too bad because it wasn't too hard to change 25 into base 5. But they get harder. Okay? They do. Okay? Ready? Do it. I want to see again. Last period, 3 students got it right. I gave them about a minute and a half. Let's see if you can. First, you got to get the bases to be the same. 1/2 is not 8. 8 is not 1/2. Get them to be the same. What did you do? you went 1/2 to the 2x equals what? 1/2 to the 8 to the negative third is 1/8 to the third, which is 512. 1/512 equals what? Nope, doesn't equal 1/2. See, that's why this one's hard. So close. Microscopic. Because that would be, well, no. Oh, why are you changing 1/2? You want it to be 1/2. You want to change 8. Make 8, right? No, you want them to be 8 to the 1/3 equals 1/2. Well, so look at your base. Your base is 1/2.
Yeah.
And now your base is 8. Those are not even the same.
So then you do
You have to get it to say 1/2, base 1/2, base 1/2, base 8, base. You can change your base to anything you want.
so it would be this because that's 8.
Yeah, that's 8.
And then
Yep. And now you got base 1/2. Wait. Base 1/2. Good. When I look here and I look here, your base is 1/2, your base is 8. Yeah, but now. No, it's not. I'm trying to figure out what you did wrong. I can't see it wrong. Hang on, I'm coming back. What'd you guys do? No. Yes. What'd you do? Yes. No. Okay, we gotta go. Okay, here's the deal. You guys, this is hard because some of you think if I change the base and I get it to say, and I don't even know how your mind thinks on this, because I remember when I did this for the first time, I remember thinking, what the heck is going on? Okay, you need it to say 1/2, 1/2, or 8 and 8. Or you can change it to anything else, anything you want. So is there more than one way to do this?
Can't you do -3 to make it 8?
I don't know what you mean.
Like if you raise it to -3, because then wouldn't it switch to 2?
Okay, wait. You want me to leave it 1/2? Is that what you want me to do?
Yeah.
Okay, so I think we're going to stay with 1/2. Okay, ready? 1/2 to the 2x, good. You have to do this now. Listen, this is what I would do. I'd write down x plus 1, but then I'd say, I want 8 to become 1/2 to a power.
I meant like make 1/2 8.
Oh, you can do it that way too, but
Oh.
I'm sorry, I didn't get what you're saying, I'm sorry. So I'm going to go like this to start with. Would you guys tell me 1/2 to what power gives you 8? Okay, so guys, go like this, go inside there and say, is 1/2 to the -3rd really 8? Flip the 1/2, flip it, you get 2, raise it to the +3, you get 8. It works. This is correct. Okay, I'm not saying you have to do it this way, I'm just saying this one works. So this is 2x equals, and this mess is what? Okay, this, if you solve it, you're going to get -3/5. Okay. But wait a minute, I just want to show you that you didn't have to do it that way. Somebody else tell me what they did. Go ahead.
I switched 1/2 to 2, and then I made that exponent -2x.
Okay. So you left, okay, I think you went like this. Okay, guys, Cassie is doing this. She's saying 1/2. I'm going to change it to base 2. So she says 2 to the -1 raised to the 2x this is working. Isn't this really 1/2? Yeah? Okay, see that 8 up there? Okay, how do I get 8 to be base 2? 2 to the what? 3. 2 to the 3 is 8. Okay, so what she did is basically made them both base 2. What's this? Negative 2x. What's this? 3x plus what? 3. Guess what? Same answer.